Let's simplify these negative square roots in terms of I. So problem 1 is the square root of negative 64. So using the definition above, we could expand this and say it's the square root of negative 1 times 64. That's the square root of negative 1 times the square root of 64. We defined the square root of negative 1 to be an I, and the square root of 64 is 8, so we put that together and we get 8I. Now it's not necessary to always show these steps, because what you can do is just simply simplify it by pulling out an I, since we see that negative, and then the square root of 64 is 8, so we have the 8I. So on question 2, 50 is not a perfect square number, so let's look at our list of perfect squares to see if we can find a value that goes into 50. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 25 works. So let's go ahead and split this up as the square root of negative 25 times 2. I'm going to pull out an I, so I have the square root of 25 times 2. This is all a product. The square root of 25 is 5, so we bring the 5 out with the I, so we have 5I, and then we have the square root of 2. Now your textbook, sometimes textbooks put the I coefficient at the end of this, so they write it like this, 5 square roots of 2I, and they're kind of treating the I like an X variable, so you can also write it like that. Question 3, negative square root of negative 4. Well, for one thing, these double negatives do not multiply together and cancel out. So what we need to do is we need to get rid of this negative inside, so we're going to pull out an I. Keep the negative in front though. So I have negative I square root of 4. Now the square root of 4 is 2, so we have negative I times 2, or negative 2I. Question 5, pull out the negative. So we pull out an I square root of 29. So if I try to find a value that goes into 29 from my list of perfect square numbers, there isn't one. So this is as far as we can simplify that problem.